Assalamualaikum and greetings to everyone. In this video, our group will explain many solutions. I will explain given a system of linear equations. Our linear equations is x plus y equals to 1, 2x plus 2y equals to 2. From that, we write it as in matrix form, which is A equals to 1, 2, 1, 2. This will give our determinant of matrix is 0. How do we get determinant? Which is we just insert it into the formula A D minus BC. I will write here. A is 1, D is 2, B is 1, C is 2. So we will get 2 minus 2, we get 0. So from the determinant, we will know that the solution is not unique. The solution is not unique. So using the rank method, reduce the augmented matrix to reduce row echelon form by elementary row operations, which is arrow, and we will get this using this. If you guys have forgotten, we just insert it into this. So negative 2 R1 is 1 plus R2 is 2, so we get 0. So we know from here that our rank of matrix is 1. So the number of unknowns is 2. So 1 is lesser than 2, which means there is at least one free variable, which is y. So next, by Gauss-Jordan elimination method, we obtain x plus y equals to 1, y equals to c. Y is a free variable, so we can assume it as c. We can use any other alphabet, A, T, or anything else. So from here we will get x equals to 1 minus y. So since y is c, we will get x equals to 1 minus c. This yields into x equals to xy equals to 1 minus c. Note that c is free variable. We can also write it into this form. How do we get that? X, y equals to x y equals to 1 minus C plus 0, 0. X, Y. We take out, we move 1 to here. Then we got negative C plus 1, 0. Next, we take out C. Then we will got negative 1 plus 1, 0. And that's how we got this. Okay. Suppose we want to obtain a particular solution. So we need to let C into any real numbers. So here we let C equals to 1, then we get X equal to 0, 1. How do we get that? We insert the value of C into this formula. This one. So C is 1, so 1 minus 1, we got 0. C is 1, so we got 0, 1. Then we let C equals to 2 from here too. So we get 2 minus C, we get 1 minus C, we got negative 1, and then C is 2, so we put it as 2. So we got X equals to negative 1, 2. This both is a solution. That's all for me. Thank you.
Okay, now we go to the question B. Given an augmented matrix of a system of linear equations in its row echelon form as follows. Okay, now by looking at this matrix, we find that the rank of the matrix is 2, which is this 1 and 2. The 0 down there doesn't count. So 2 is less than the number of unknowns, which is 3. Sorry. Okay, 3, the number of unknowns, X, Y, and Z. Thus, it has many solutions. From the augmented matrix, you can see that X plus 2Z equals to 2, Y plus 3Z equals to 3, and Z we can equals to C, because C is the free variable. It can be any number. Okay, now we go to the back substitution. So just now we get X plus 2Z equals to 2, so we can let the X equals to 2 minus 2Z, Y equals to 3 minus 3Z. Then we can let X equals to 2 minus 2C, and Y equals to 3 minus 3C, which gives X like this, equals to 2 minus 2C, and Y equals to 3 minus 3C, and Z equals to C. And then we can let the equation to be in the simplest form by factorize it. As we can see, all of 3 equation we get C, so we just get out C outside of the matrix. So that's it. The final equation is this. So we can substitute C with any value, such as we substitute C1, so we get -2, -3, 1 plus 2, 3, 0, and we get 0, 0, 1. X, Y, Z. So the answer is X equals to 0, Y equals to 0, and Z equals to 1. So that's it for C equals to the 1. Now we can substitute C with other numbers such as C equals to 2. So we get -2 times 2 is -4, -3 times 2, -6, and 2, plus 2, 3, 0 equals to -2, -3, and 2. So the final answer we get X equals to -2, Y equals to -3, and Z equals to 2. So this is what we mean by many solutions. We can get many solutions by substitute C with any number. The answer will be different. So that's it for question B. Thank you.
Now I'm going to explain the third example of many solutions. Firstly, this matrix need to be reduced in order to find the position and value of free variable. This can be done by using arrow method. After using arrow method, we get this. From this, we can see that the rank of this matrix is 3, which is less than 4. 4 is the number of unknowns. Thus, we can say that it has many solutions. So now we need to take out the values, now we need to take out the equations from this matrix. So for example, x plus 2y equal to 1 and z equal to -4 and w equals to 3. Since y is a free variable, we can substitute y with c to show that it is a free variable. By doing that, we can get this. We need to take out any numbers that are not related to c, for example the 1 here and -4 and 3, so that we can factorize c out and we get this.